Hi everyone, my name is Noe and in this video I'm going to explain you what a trie is in data structures and algorithms. So we have a brief explanation here. So a trie is an special tree-based data structure. It is used to store and retrieve strings efficiently, especially when operations depends on prefixes. This is a kind of common kind of questions that you will see in interviews. So you might want to watch this video. So we have an example here. So we have these words, cat, car, and dog. And basically we are going to be creating a tree structure as this one. We have CA, and the children of A are T and R. So as you can see, we are not repeating CA from cat and CA from car. We just have one branch with CA, and we have T and R as children of A. For dog, we just have a unique branch. So that's what we have. So this is the structure that we are going to be building. So why we do this? Because it is more efficiently to search for example, in autocomplete systems, for example, if you go to Google and start typing some words, you will see that it tries to guess what you are trying to search and it puts below the box like trying to autocomplete the word, right? So it's very common to use on those systems, also for spell checking, for IP routing, for example, for word games like Scrabble, you will use that under the hood. So it is more efficiently to search for things in these structures. So let's see the Python implementation here. So we have two main classes. The first one is node. It's pretty simple. It just has two attributes, children and isWord. So in this visual representation, each letter is a node. So C is a node, I is a node, T are a node. All of these letters are a node, are objects of node type. So, and each node you can see has these two attributes, children and isWord. It's very obvious that T and R doesn't have children, but A, it has children, T and R, and C has one children, which is A. And the other attribute is word. This is very important because this is where we mark at which part of the branch we have a word. So for example, only on T and R isWord is equal to true. But for example, if we add, I don't know, the word CA, I mean, that doesn't exist. But if we add CA to the list, we will need to mark A as isWord equals to true. So that's a very important attribute. But as you can see, this is a pretty simple class, which will be represent each node in the branch. Now the bigger class trie, it represents the whole structure. But before explaining that class, let's jump to this part. So this is where everything will be executed, right? We have a list of words: cat, car, dog, castle. We can even add more words to the list. So for example, I don't know, cantina, that's a Spanish word. And we are going to be creating an object of the trie, which is the biggest class. And then we are going to be inserting. You can see trie, it has a method called tree, this one. Don't worry, we're going to be explaining that. But it's just receiving a word. That's why we are iterating the words. For word in words, insert that word. And then it has another method which is autocomplete, and this one you just need to pass a prefix. In this example we are passing CA as the prefix, and at the end the result will be containing all the words that start with CA. That's what we're going to be doing. Now let's explain the tree. The first part is just inserting the words. So let's start by doing that. And let's explain the insert. Oh, just before that, in the constructor we have the main node, which is sometimes called root. So we have a root node. So self root equal to a new node. So it will be this one. So, and of course, the children of that node will be C, D, and I think that's it. We don't have other words that start with different letters. So that's our root node. And all right, let's explain the insert method. It receives a word. So we are going to be working with one single word in this method. We are going to start by getting the root node. So node equals to self that root. All right, and let's start working with each character in the word. So in the first word we have cat. So for character in word, so that means we are going to be working with C, the next iteration with A, and the next iteration with D. So that's what we are doing in this for loop. All right, let's start checking if that character is not part of the children of my node. I'm gonna be adding a new node to the children. So all right, let's explain that in simple English, right? At the starting point, the root node has children empty, has a dictionary which is empty. So, and we are iterating the word cat. So we are checking, it's the letter C part, or it's a child of the root node. It's not. So let's add that as the key, and let's add the value a new node. So in few words we are doing this. We are adding C. You can see we are using that as the key. Let's see. All right, character, we are adding that as the key. That's what we are putting here in the brackets, and the value for C, it's a new node. So a new node, right? A new node. Of course, this is not valid Python syntax, right? I'm just explaining you. So that's what is happening under the hood. So all right, and then once we do that, we need to update the reference for the node variable. We do that because we want to add children as child of the previous node. So that means we added C to the children of the root node, right? Then for the next iteration, we want to add A as child of C, not of root. So that's why I am updating node equal. You can see it's the same colors, right? So I am updating the value for node to the reference of the new node, which is the node for C. So all right, next iteration it's for A. So A is in the children of C because that's the new reference. So it's not. So okay, let's add that. And that's what it's going to be happening in all of the characters. And at the end, we are marking the final node attribute as true. Is word equals to true. So for cat, the last node will be marked as is word true. And that's obviously right because that's the end of the word. So that's why we are marking that last node as true is word. So that's basically what we did. So let's kind of visualizing this. So the first iteration, we are adding C, and we are adding a new node, right? The second iteration, we are adding as a children. Again, this is not valid Python syntax. I'm just trying to trying to explain you in a visual mode, right? So second iteration, we are adding A to the children, and the value is a new node. And finally, the children for A, it's T. Let's put like that, T. And that's a node. But this node has its word equals to true. So basically that's what is happening under the hood. So that is this part, cat. Let's just erase that part. So hopefully that you get that part. So that's how we insert words into the structure. Now, what happened with the second word, right? Car. Let's see. It starts by checking if C is already in the structure. So, okay, yes, C is already because it was added by cat. So, okay, let's continue. The A is added. Yeah, it's already a child of C. Okay, let's move on. R is not a child of A. So, okay, here we are adding, I don't know, a child, right? Something like that. Right? These are the children of A. And that's how we are populating the whole structure with just this method. Now, this is just the first part. The most important part is just to retrieve the data. So we are going to be using this method, and we are passing a prefix. For this example, we are going to be using CA. So I want this method to return a list of words that start with CA. So that will be cat, car, castle, and cantina. So those are the words that start with CA. Now let's explain this method. It receives a prefix, and this first part, basically in this part, we are retrieving the reference of the last character in the prefix. That means, in this example, we are passing CA. We need to get the reference of A. Just to put another example, let's say we pass the prefix cast. In this part, I need to get the reference of T. All right. Hopefully that you get that part. So let's explain the code. We start by getting the root node in this variable, and we are going to be start to iterate each character in the prefix. So first iteration C, second iteration A. That's where it's going to be happening, this for loop. So all right, if the character C, it's the first one, remember, is not a child of root, okay, if it is not at this level, all right, that word is not in the structure. And that's obviously right. The root node has this children attribute, and all of the keys are the first letter of the word. So if the character is not part of the children, all right, we are done. We just return an empty array. So there's no words that start with that prefix. But of course, if this is if we don't enter this if, in other words, if the character is in fact a child, we need to continue the for loop. So what we're now going to do, it's just to update the reference of the node variable. Because remember, at the beginning, we have the reference in this variable equals to the root node. So if the character is in the prefix, sorry, if the character is a child, let's update the reference. Because again, we need to get the reference for the last character in the prefix. So in this case, we need to get the reference for A. So that's where we are updating the reference for the node. So that's the first part, and that's what it is happening in this part. And finally, we need to get the words that start with that prefix. And for that, I have this other method, which is called collect. Just a curiosity, I have here a variable that is called results. It is equal to an empty array. You can see I am passing this variable to the collect method. Now, something interesting about Python is that when you pass an array as an argument of a function or a method, you are actually passing the reference. So whatever I do to results inside collect, it actually is affecting this result in line 31. So that's how Python works. And actually, I am like kinda taking advantage of that, because otherwise I will need to go to collect and type, I don't know, return something, and then here I will need to type results equals to this thing. But I mean, since Python already is actually modifying the actual results, I am just taking advantage of that. Anyways, we have the reference for the last character in the prefix. We need to pass the node, that reference. We need to pass the prefix, in this case it's CA, and the reference for the array. And at the end, we're just going to be returning that list of words. Now let's see how this collect method works. It receives a node. In this case, will be the reference for A. So that's what we have here. Prefix, we are passing CA, and results, it's an empty array. So let's go up here. So let's put a comment. So the first thing, it's okay. I am passing the node, which is the reference for character A. And also the prefix is CA, and the results is just an empty array. So let's work with this information. Okay, if node is word, okay, if the reference is marked as word, just add the prefix to the results. Now in this case, CA is not a word, right? We don't have CA here, so we are not adding CA to the results variable. But okay, that's a first check. Maybe in the future we will have that scenario, so we need to have that at the beginning. Now, starting for this point, we need to check, we need to traverse all of the branch at the end. So that's why we are iterating node that children. So in this case, node is the reference for A. So at this point, we are iterating, it's a for loop, you can see. We are iterating all of the children. So we are iterating for T and for R. So you can see we have an items method. This is a method for a dictionary. You can see here an example. This is just a separate example. I have here my dictionary equal to this dictionary, and if we use the items method, we return an array of tuples. The index 0 is the key, you can see name, and the index 1 is the value, Noe. You can see index 0 key and 0 value. Anyways, that's what we are doing here. Let's iterate the children of the node. Okay, let's iterate for T and for R. What we're going to be doing with that information, we are doing a recursive call. We are calling Colette again here, you can see. So let's pass the node, which is the value, the prefix, and we are appending the new key. Now at this point the prefix it is equal to CA, and we need to append the new key, which is in this case T. So we are passing, let me just copy and paste the same thing, children. So in this thing, the second iteration, I mean in this iteration, I'm working with T and then plus T. T. We are just passing cat. I mean, we are passing cat, and results at this moment is an empty array. With this, with the information, okay, let's work with that. Note is word. Yes, T is marked as a word because that's the end. And of course, that's what we do in the insert. At the end of the inserting method, we are marking the isWord as true. So T, in fact, yeah, is marked as a word. So let's add that prefix, which is cat, added to the results array. So, all right, we have something here. So we have cat. Now, let's iterate the children of T. No, we don't have children, so we are done with that. And since this is a recursive call, we are not done. We need to work with R, because at the very beginning, remember, we were iterating with the children of A, T and R. We are done with T, and now it's the turn for R. Let me just copy and paste the same line. So now it's the turn for R, and of course, now the prefix is CA plus the key, which is R, car. Okay, let's work with that. Note is word, yes, is marked because that's the end. So add that prefix to the results. So alright, we have a second word here. We have car. And this is going to be happening, of course, in this example is not the same as this one, because we are missing castle and cantina. So we need to have more iterations, because we have here, I mean in this example we will have here castle, the branch, and then we will have the cantina branch. So the process will continue, and basically after a few iterations, after a few iterations we will have, let's see, we will have castle, and finally we will have cantina. So that's going to be happening in the results array, and we are returning that results here. We are putting that results in the rest variable, and we are printing the rest variable. So let's see that in action. Python tries.py. Okay, yes, cat, car, castle, cantina. Now let's just see a few others. For example, what about a non-existing word? For example, I don't know, que, something like that. Just check, and yep, it's empty, because Q, we are starting here. For character in Q, we start with Q. Q is a children, is not a children. Yes, it's not a children of the root node. So just return an empty array, and we are done. Now, what about if we pass the castle, cas? let's run that, and we are just putting castle in the results array. And this is pretty much how the tries how tries work. Again, this is more or less a common um, questions or something that you will see on interviews. So just try to watch the video again or just ask questions in the comments. But that's pretty much it. So I'll see you in the next video. Bye.